Alright guys, today we are going to review multiplying monomials and polynomials. This PDF that I'm going to work out some problems on is the same as the assignment that you have in Go Formative today, so I would recommend you guys working out the problems on your own scratch paper, and then you're just going to enter your final answer on Go Formative, and it will tell you if you got it right or wrong. Okay, so let's review an example of each type of problem here. So I'm going to do number 1 first. Our directions tell us to simplify, and it says that our answers should contain only positive exponents. Okay, so when we are multiplying two monomials together, remember when they have the same variable, we add the exponents, okay? But the first thing you have to remember to do is to multiply your coefficients. So here my coefficients are 3 and 3, so we would just multiply those like normal. 3 times 3 is 9, and then we look at our variable. We have k to the third and k squared. Because these are the same variable, we would add our exponents, and 3 plus 2 would leave me with k to the 5th power, and that would be our final answer. We would do the same thing on numbers 2, 3, and 4. Be careful on numbers 3 and 4, and remember that we can only add the exponents on the variables that are the same letter. So in number 4, I have an x and a y here, but remember we can only add the exponents when they have the same variable. So you would be adding x to the second and x to the third, and then y to the third and y to the fourth. There's a little hint on that one for you guys. Okay, and then numbers 5 through 7, this is reviewing our power to power rule. So remember when we're raising something to an exponent and then you raise that whole term to another exponent, this is when we would multiply those exponents together. So b squared raised to the 4th power would become b to the 2 times 4 power, which would give us 8. So my final answer is b to the 8th power. The only other thing you have to be careful with on these types of problems is that if there is a coefficient different than 1 out front, meaning there's a number in front of your variable, you have to also raise that number to the exponent outside of the parentheses. This has to be distributed to both pieces here. So on number 6, if I were to rewrite this problem in expanded form, we would really be doing 3 to the 3rd power times x squared to the 3rd power. If you don't know what 3 to the 3rd power is, remember this really is just 3 times 3 times 3, which would give us 27. You can plug that into your calculator. And then x squared raised to the 3rd power, this is where we would multiply those exponents, and we would get x raised to the 6th power. And that would be your final answer on this problem. You would do the same thing for numbers 7 and 8. Be sure you're distributing that exponent outside of the parentheses to each little piece inside the parentheses. Okay, then on numbers 9 through 14, we're going to have to use the distributive property. So let's do number 10 as an example. Remember, the distributive property tells us that we're going to take this term outside the parentheses and we're going to distribute it to each term inside the parentheses. So first, I have 3m times negative 8m. So this works just like the product rule that we did in number 1. We're going to multiply our coefficients, so 3 times negative 8 is going to give me negative 24. But now I have to multiply my variables and add the exponents that are attached to them. So remember, if I have just a letter, there's an imaginary 1 in the exponent there. So really, I'm taking m to the 1st times m to the 1st, and when we add those exponents together, we would get m squared. So make sure you're being very careful with that. Then we distribute 3m times 2, and we would get plus 6m. And that would be your final answer. So again, for numbers 9 through 14, you were just using the distributive property. Then on numbers 15 through 22, you are using one of the three methods that you learned about last week on Friday in that Ed Puzzle video. Oh, wait, I'm sorry. We actually did that yesterday in class. The Ed Puzzle from Tuesday in class, my bad. So if you watched that Ed Puzzle video, and if you haven't, make sure you go back and watch that. But there was three methods that we could use. There was the distributive method, there was the box method, and there was the FOIL method. So in these examples, I'm going to be showing you the box method and the FOIL method just as a review. When you are solving these problems, you can decide which method works the best for you, but these are the two that you're going to see most often. So it's important that you remember how to do both of those. Okay, so let's start with the FOIL method. If you remember from the video, FOIL stands for first, outside, inside, and last. So if we start with first, that just means we're going to multiply the first term in each binomial. So I have n times negative n, and that would give us negative n squared. Remember, we're adding those exponents. So 1 plus 1 would leave me with 2. Then we're going to do outside. Our outside terms are n and plus 1. So we would multiply n times 1, and that would give us plus n. Then we have our inside terms. Our two inside terms are 3 and negative n. So 3 times negative n would give us negative 3n. And then last would mean the last two terms in each binomial. So 3 times negative 1, 3 times positive 1 would give me plus 3. Now our only step left is to combine like terms. So here I have a plus n and minus 3n. So when I combine those, I really have 1 minus 3, which gives me negative 2n. And then I would just fill in the rest of my problem since there's no other terms to combine. And my final answer would be negative n squared minus 2n plus 3. Okay, so that's an example of the FOIL method. Now let's do an example of the box method. So I'll come down to number 17. Because we're multiplying a binomial times a binomial, when we draw our box, we need it to have 2 rows and 2 columns. With the box method, we're just taking each binomial and we write the first one on top, m minus 5, and we would write the second going down the side, so negative 2m plus 3. Then with the box method, all we're doing is in each little box here, you're multiplying the two terms that meet or intersect at that box. So with this first box here, we're taking m times negative 2m. Okay, and you don't have to write what we're doing here. I just wanted to show you that extra step. So m times negative 2m is going to give me negative 2m squared. In the next box, we're doing m times 3, which leaves me with 3m. In the next box over here, we're going to do negative 5 times negative 2m, which is going to leave us with a positive 10m. And in the last box, we are doing 3 times negative 5, which leaves us with negative 15. So your last step here is to just write each of these pieces as an expression by adding them all together. So I have negative 2m squared plus 10m plus 3m minus 15. And my last step is to combine like terms. So I have 10m plus 3m, which would leave me with 13m. So my final answer is negative 2m squared plus 13m minus 15. And if you did the FOIL method or the distributive method on this problem, you should get the exact same thing. Okay, last example that I want to do for you guys is number 21. So number 21 is written as a binomial squared. So remember that when we're squaring something, we're just taking that term or that binomial and we're just multiplying it by itself. So 2v plus 4 squared is actually 2v plus 4 times 2v plus 4. And now you have a binomial times a binomial, which is just like the examples we did in numbers 15 and 17. So let's go ahead and work that out together just to show you guys one last example, and then you can try the rest on your own. Okay, so I'm going to do the FOIL method again for this one. So remember, F means first. So we're multiplying our first term in each binomial. So 2v times 2v would give me 4v squared. Then O stands for outside, and our outside terms are 2v and 4. So 2v times 4 is going to give me 8v. Then I stands for inside. Let's not use red since that's the color we wrote in. I stands for inside, so my inside terms are 4 and 2v. So 4 times 2v gives me another 8v. And then L stands for last, and my last terms are 4 times 4, which is going to give me 16. And again, our last step is to combine like terms. So my final answer is going to be 4v squared plus 8v plus 8v is 16v plus 16. And again, you could have done whatever method you prefer for that type of problem. And number 22 would be the exact same way. So write out your term 5x minus 2 squared as 5x minus 2 times 5x minus 2. And then you can use one of our distributive methods to help you solve. Okay? So try the rest of these on your own. Again, like I said, if I were you, I would do them on my own paper first, and then you're just typing in your final answer onto GoFormative to check your work. If you have any questions, please email me. Have fun.